All right, so now what we're going to look at is specifically why there's an average number here, okay? Because this is our atomic mass. So this is the number we're going to focus on. This is our atomic mass. And just a reminder, if you haven't seen the introduction to Unit 2.1, check it out because it talks briefly about atomic mass, and that's protons and neutrons. This is all that makes up the majority of the mass of the elements. Electrons are a very, very small amount. So this makes up the majority of the mass of lithium and sulfur. So therefore, we just assume, since electrons are so small, so insignificant for our weight, is that we're just going to assume all of this is our protons and neutrons. But why is it an average? Because remember, protons are 1 AMU, neutrons are also 1 AMU. So you can't have a 0.5 neutron. It has to be 1, 2, 3 neutrons, 1, 2, 3 protons. These are 1. So why is there an average? You can't have a 0.066. It has to be an even number because if I have, for example, 8 protons and 6 neutrons, then 8 plus 6 is 14. The number should be even. So why is that? Well, first of all, we have to know that this is the identity of the element. Okay? This is the only element that has 3 protons. This is the number of protons. Okay? So 3 protons, lithium will always have 3 protons. It never, ever, ever changes. If you change the number of protons, you change the element. For example, if you go to 4 protons, then you're going to beryllium, and then 5 would be boron. So if you're changing the protons, you change the element. So 3 will always be lithium. Always, always, always. That's very, very important to understand. Okay? Sulfur, on the other hand, has 16 protons. Okay? So you would assume the rest of the weight is neutrons. But you cannot have, for example, 6.9 minus 3 would be 3.9. You can't have 3.9 neutrons. So why is it like that? Well, we have to go through, I'm going to erase this now, we got to go through another important word. That's isotopes. So isotopes mean different neutrons. So same element, but they have different neutrons. Different amounts of neutrons, so different number of neutrons. So what would be, so if I say, if I have 3 protons, so lithium always has 3 protons, and the number of neutrons can change, then that kind of makes sense, because then we look at it as an average. So let's look at that. So lithium has different isotopes, okay? Lithium has 6 as a mass number. This is how you write the the notation for an isotope. So lithium weighs 6, and it also weighs 7. That 6 just means that's the atomic mass. So this is the atomic mass. Okay? And so is this. So this number indicates that we're talking about one atom. So all the elements on the periodic table they're not talking about one atom, they're talking about all the atoms that lithium has. So all the atoms of lithium has an average of that weight. Okay? But individually, they weigh 6 or they weigh 7. All right? Because this atom, or this specific atom, if it weighs 6 and 3 of that is protons, then you know that this has 3 neutrons. Okay, if this is 7 and 3 of them are protons, then you know 4 of that is neutrons. Okay, so I'm going to get rid of this atomic mass because it is atomic mass, but I'm going to write that down now. So this means this has 3 protons and 3 neutrons. Okay, so the same thing here. It always is the same number of protons and 3 neutrons. Excuse me, 4 neutrons. Because 4 plus 3 is 7. 3 plus 3 is 6. So now let's look at these two and go, okay, these are the 2 isotopes of lithium. Which one is more common if the average weight is 6.9? And you would think, okay, if I'm averaging 6 and 7, and I'm averaging all the isotopes, so every single atom in the world that is lithium, all the little atoms, they weigh 7 or they weigh 6, but the average is 6.9, you would assume this is the most common, because the average of these two has to be close to this, so 7 must be the number. Because if this average was closer to 6, then I would have more lithium with 6 total weight, so 3 neutrons. But the more common lithium atom is 4 neutrons. Okay? So this is just telling you that this is the average of all the lithium atoms, because you cannot have a decimal on an individual atom. They weigh a certain amount of protons and neutrons, and it's a whole number every time. But they average these two. So the average of all these together equals 6.9. So you would think that there's a lot more lithium-7 than lithium-6. In fact, lithium-7 is right around like 90-some%. Don't quote me on this, but it's very high, 94, 95, even 96%. So most of the lithium atoms have 4 neutrons and not 3 neutrons. This is a rare element or atom. This is a rare atom of lithium. This is a more common atom with 4 neutrons. But notice the protons do not change. So maybe pause the video for a second and try to do sulfur when I tell you how many they have. So let's do sulfur. I'm just going to give you the elements first. So we got S32, S33, S34, and S36. All this means is that all there's sulfur atoms, more than one kind, I would say, or more than one they weigh differently. So this one weighs 32, this weighs 33, this weighs 34, and this weighs 36. But the average is 32.066. So in a second, I'm going to go over what the most common one would be, and also how many protons and neutrons each one has. So maybe pause that and fill in this part for this part. Okay? All right. So here's what we're looking at. So we know that the protons and neutrons are all the same. The number of protons never changes. So I have 16 protons for each one of these, because otherwise I change the element. So then I just do the rest of the math to make my neutrons. So 16 plus what equals 32, and that would be 16 neutrons. So 16 plus 16 is 32. Over here I would have 17 neutrons, and then 18 neutrons, and then 20 neutrons. I guess it would be capital. It's not a big deal. All right, so anyways, when you add these up, it equals 34. That's the mass, the atomic mass. That's the atomic mass. It's the average of all the sulfur atoms of all these, okay? So this is the exact weight of one of the atoms of sulfur. There are 4 different sulfur atoms that weigh 4 different things, right? One weighs 32 atomic mass units, one weighs 33, one weighs 34, and one weighs 36. The most common one would be the one closest to 32, because that's the average of all of them. So here is the most common one. In fact, this one is like 94%, I believe, something like that. So it's like 94% common. So if I would reach in and grab a sulfur atom, I would have a 94% chance that that atom has 16 neutrons. Okay? The rest of them are pretty rare. So it's hard. So most sulfur atoms do not have 17, 18, or 20 neutrons, but they all have 16 protons. So the average of all of the atoms, because there's billions of these, right? And the average of all of them is this number right here. So the most common one must be sulfur S32, which is the isotopic notation. So you might see, so these guys are all called, so last thing, so I'll just put a number. So let's do letter. So the symbol, let's put symbol. So if I say symbol with a dash and a number, this is called isotopic notation. And this is just telling me that specific atom has this many neutrons in it, because the protons never change with that element. For example, let's just do one more. So if I do, let's just put one right here. So if I do O and dash 16, I know that there's 8 protons in oxygen, because it's always 8, so the rest are neutrons. So this has 8 neutrons, right? But the oxygen, it has a number of 15.99. That's the atomic mass, meaning that's the average of all the oxygen atoms. When you average all of them, the average is 15.99, so the most common oxygen isotope would be O16, because you would have the number is the closest to this. So you'd have 8 protons and 8 neutrons. So please ask questions if you need to on this, but this is just a good start to trying to understand the periodic table and get used to these numbers a little bit. All right?